everybody, welcome back to another edition of the Modicon M221. I'm your host, Leandro Mada, and in this video what we're gonna see is the PID output configuration that we have in the software. So let's go to the presentation. So in the last videos we have seen how to configure the input of the PID assistant. Now let's take a look on the output size. Okay, I know that in the middle there's something called PID that we need to configure, but I just want you to understand the different configuration that we have in the output. So if we select the output configuration in the PID assistant, okay, we have different things to configure. Okay, so if we take a look in this diagram, okay, which is the one for the PID assistant, depending on the activation of the output features, okay, we have different views. For example, here in the action, okay, basically we will be how the output is, or how the system reacts with the output of our PID. So here we have three different configuration: direct, reverse, or bit address. That basically this bit address allow me to select if I want reverse or direct. Okay, now I'm going to explain later in details. Then we have the possibility to specify the limits. So here are the limits. We can use this bit address just to enable or disable the limits. Okay, and we have for min and max limits, and it's going to be the limits that I want from the action of the output. It's not the same as the conversion that we have in the input, that you have the input and then you have the conversion, and you can specify the signal to go to this size, okay, and you have like conversion. Here on the output, even if you generate a signal, okay, like this with the conversion, and you get this part, okay, just comparing the size. If you use the limitation, okay, probably the signal, if you have this kind of signal, it just go to here and it's going to stay in there, okay, and go. It's just a limit of the value. It's not the conversion, so you need to be careful here. And the thing that we have also here is the manual mode. So we imagine that you're working with the PID, you're trying to you're working with the PID, and then you just need to see the behavior that you have with the plant with a specific value. Okay, if you're using the PID will calculate the value for you, the output. So sometimes you will need to override that value. So one way to override that value that you have of the output of the PID is to use the manual mode. And here you can select a bit boolean to activate or deactivate the manual mode. Then you need to specify a MW variable that contains the manual value that you want for the output. And then finally, the analog output, that will be the output of the PID, okay? So it must be a percentage MW. So far here, we have seen the different configuration of the output, okay? So I have the action, how it's going to react the process. I have some limits in case the output of the analog output go from 0 to 10,000. So probably you can limit that that action of the output. So you can do this with the limits. If you want to make a conversion, you will need to do it later. Another thing that you can do is to use a PWM output, but this I'm going to cover in the next video, so we can play fully with the output in PWM. Now, let's hide myself a little bit. So this is a little bit more about the explanation. So this is the limitations, okay? So the output generated, okay, for the PLD will be with the limits min and max, okay? So it's not the same as a conversion as already explained. This action, okay, can be reverse or direct, and you can link a percentage m variable boolean, as I'm doing here, okay, to change between reverse and direct. Okay, here is something important, because probably if you read it just like that, you're probably thinking is the wrong name. Probably I know 100% agree with the names, but this is how it is. So basically, reverse, okay, the action reverse is like, for example, imagine a heating system. So you have like a heater, okay, and you're gonna turn it on in order to increase the temperature. So as soon as you turn on the heater, okay, the output that will be the temperature, or the value that you're going to read is the temperature of the room, will be increased. Okay, that is how we called in the software, okay, reverse. Okay, so any action that is going to increase the temperature, okay, if I increase the output of the PID and I have an increase of the value that I'm measuring, okay, that is going to be reverse. Okay, and that's why the heating is a good example. In the opposite way, we have the direct. So an increase of the output, okay, imagine a cooler with a fan. If I need to reduce the temperature, okay, I'm going to increase the action of the fan with the cooler, okay, to reduce the temperature. So an increase of on the output of those values, okay, will reduce the value that I'm reading for the PID, and that here in the software is called direct. So as you can see over here, an increase in the output causes a process value reduction. An example could be the cooling. Something important here, if you want to take a look in the formula, okay, this affects how the KP interacts. So in this heating process, okay, the KP has a positive value, and in the other way, in the cooling, the KP should have a negative value. Okay, that is basically how it can work. But the important thing is that we need to analyze the process that we have, how the output is going to affect the value that we are going to read. Okay. Now, for the other ones, it's very simple. We have the manual, and we have also the output signal that can be linked to a percentage MW or analog output. Okay, I usually link it to a percentage MW, and then make some kind of conversion, and then goes to whatever it needs to go. And then the other value that we have here is for the PWM that we cover in another video. So let's check the configuration in the software. So here, programming, configuration, programming, tools, software objects, PID. I'm going to check this one, which is the dummy that I have. So the outputs. Here are the different configurations. This is just an example, okay, how it can be used. But the idea is to identify which are the variable type that you can use. As you can see here, the output percentage MW, the output when it's manual MW, the bit for the selection to activate. Okay, and let me just double check. The real one that I'm going to use is this. So you can see all the icons, and if you click on the icon, you should be able to go where you want. In my case, I'm not going to use the limits because I don't want to use them. And what I have done also is the output of the PID, okay, I have like a scaling. So for example, if you want to send the set point for a drive, okay, I have the max value, which is this one, the output, which is 10,000. Okay, it's gonna be one of my points from 10,000, so 0 to 10,000, and then I'm going to escalate from 0 to 500. 500, that's going to be 50 hertz. Then I will have the linearization. That is what I'm using over here. So let me just double check one thing. So I just want to check if I have all the variables to make the test. PID action mode, I haven't specified the manual mode. So let me just double check. PID configuration, I have a manual, but it's the M58. So PID M58, M58, insert. Okay, so I'm not going to go into details about the values I should have for a KP, TI, or TD. No, I'm going to show you the different configuration and how each configuration has an effect on the outputs. So I'm going to connect with the controller. Okay, and let's see, PC controller, download, and then run. So this is my PID, the calling. I have this block to simulate the input. Here in the PID mode, let me just double check what do we have. PID here. I'm going to enable the PID just to see what do we have. There is some kind of error over here. Okay, no problem. PID mode, I believe number 1 is for the PID. As you can see, most of the parameters are in 0. So this one I'm going to put like this. The KP, if it's 0, I believe is going to assign 100, so I'm going to use number 12 over here, and I have the set point and the process value. So as you can see here, depend on the formula. Okay, this will depend on the formula and some of the parameters I'm going to see later. In this case, as I have all this in 0 TI and TD, I have a different formula, and I have this value and the output. Okay, we're going to see that later, but this is going to be the value. So imagine that I'm going to control the temperature. So the set point, let's see, is going to be 23 degrees. Okay, so as you can see, my process value is in 0, so this will try to increase. So I'm going to have like a positive value, okay, on the output. Let's try to add, I don't know, like this. 10. 1, it doesn't matter. As you can see here, the output will be increasing because the action requires that, okay, my set point is very high, my process value here, so I'm going to have an influence on the plant to increase the value. So I'm going to try to increase this part. Okay. You can see it reached the everything, the max value. So I'm going to use, for example, for 80, and I'm going to probably decrease the DS because this is how the samples works. I'm going to delete the 0, the TI. Okay, so here you can see how imagine that my middle will be the 5000, so I have already reached the point that I have an error, I need to decrease that. So let me just delete this. So PB 230, and this one is gonna be 20 degrees. So you can see that I have an error. Okay, this is the output, and the output is below, so is above. So in this case, okay, it's reverse, and it's going to try to reduce this value. If it's more higher, for example 1 degree, the action of the output is higher. So as soon as I start decreasing this, decreasing the error between the set point and the process value, as you can see here, the error, this is the error. So I'm going to use 200. The error is lower, and the lower is going to be the action of the output. As soon as I reach the value, it's going to be 0 the error. Okay, so in this way you can see that this configuration is a reverse. So as soon as I increase the output, it's going to increase the input. That's going to be the effect. So imagine now that okay, so the set point is in 0. So as you can see, there is an increase of the output. Now, what happens if I, instead of selecting the reverse, I select direct? So it means that the KP or the actual KP will be in the other way, because as soon as I'm below the set point, I need to reduce it. So I'm going to select direct. As you can see, I'm going to decrease the value of the output, so the process value that I'm going to read is going to increase. As you can see here, the action before it was below above the 5,000, now it's going to be above the 5,000. So as soon as I reach the set point from the process value, the error will be reduced. So 100, the error, the output has been close to the one that I want. As you can see, the error that you have over here. Okay, so as soon as I reach the value 5,000 is stable in what he thinks is stable. Okay, so now if I need to specify a manual value, okay, I forgot what was the variable that I use for this. So PID 1017. So the view 1017 insert. So 1, 2, 3, 4, whatever I want. So as soon as I put this in manual, you should have this value on the output. And there we go. Simple as that. So the important thing here is to identify which is the right action that you want for the plant. Okay, I already taught this part. Check the limits. I don't want to check it, but it's gonna be simple. Let's check it. Yeah, let's check it. So we know, for example, when we are let's have a look into this. So imagine that the process value is 0, and if I activate the TI, the error will try to reach, the error will try to go to 0. So in this case, will increase to the value, to the max value in this case, if I keep it growing. Keep this growing. Just put something else here. And I need to use the reverse. So this will keep growing and growing. So what I want to do now, okay, this will try to reach the 10,000. We go to max, the max value, to try to the process to start increasing. What we can do is to limit the output so it doesn't reach the 10,000, something lower. So for that, what we can do is to go to the PID. Here output enable. I'm going to enable, so it's gonna be I don't know, the limit's gonna be 0 and 5,000 or 4,000. Okay, the limits should be another one, should be higher than that. Could be it should be between 0 and 10,000. So I'm going to apply. I'm going to log in and download, and as soon as I with the controller, okay, the output should be 4,000, but it would depend on what I have, what is the actual process, but just to give you an idea how it's going to work. So PID, manual action, PB, let's try to do one thing, because based on the formula I just try to go to the 5,000. Okay, so as you can see, even if I need to give more power, okay, to the output to reach, it just doesn't go to the max, which is 10,000, because I have a limitation over here. Okay, that's why the start, and the reason why I start from 0 is because I download again the PID and we start from 0 when it's doesn't have the formula. But this is the limit. This is how it works. The limit is not a conversion, it's just a limitation of the output. Okay, in theory, if I don't have the limitation, it will go to 10,000, which is the max possible value that the output may have. Okay, so this is it for the output, for the analog output of the PID block. Thank you very much for watching this video, and I see you on the next one.